Hello, good evening. So you asked me to do a written video based on mechanics. So mechanics, it's basically we start. It's basically your motion in one dimension, and it's basically your vectors and scalars. So I'll just quickly go over vectors and scalars because I want to finish the mechanics just in one video, right? Because you take time to respond. So even when you take time, at least we covered everything. So the vectors and the scalars, this is where everything in physics starts from. These are the basics of physics. So your vectors and scalars, um, these are the quantities we use in physics, right? So your vector being a physical quantity that has both magnitude and direction, right? This one is both magnitude and direction. Whereas your scalar quantity only has magnitude. The way I would remember this is I think of scalar, back at Cassie, when you say scalar, it's not alcohol, brute alcohol, right? So scalar, you can't measure the direction of a scalar, right? But scalar has magnitude, it has the amount, that's the size. So that's how I remember it. The scalar only has magnitude, whereas vector is both magnitude and direction. So the examples of your vector quantities are things like your force, right, which is measured in newtons. It has both magnitude and direction. Things like your weight, your your displacement, right, your velocity, not your man. All these examples are examples of your vector, right? It's your force, your weight, your displacement, your velocity, your acceleration, and so forth. And then your scalar examples would be things like your mass, right? Your mass, we can't say you so and so is mass of this much to this direction. No, it's just there, right? Your mass, your distance, your speed, right? Those are the things, your temperature, your time, all those are examples of the scalars, right? So when it comes to physics, we normally represent these vectors and scalars using the graphical representation. But to be more specific, there's no graphical representation we ever use for scalars. So every graphical representation, when we represent something in form of a graph here, it means that that particular thing is what? It's a vector. Now I want us to quickly look at the graphical. So let's say this is your graph, and then you have this thing, then you'll be given an arrow like that, right? So you'll be given something like this. So when you have something like this, what I want you to know is that this until there shows you the magnitude, and this arrow shows you what? The direction. So hence I'm saying that there's no graphical representation that will be showing you a scalar, right? They are all showing you a vector, right? So the length of the arrow is the magnitude of that vector, and then the arrow, the direction of the arrow is the direction of the vector, right? And the direction obviously will be depicted here. It will be shown there in form of a theta or whatever angle, right? We'll come to the different types of directions that they can use graphically, right? So that is that. Sometimes they can just throw it like that, and then they tell you that it is 5 newtons. So this is 5 newtons going to the right because the arrow is going to the right, and then the other one maybe might be 3 newtons going to the left. And normally when they go to the left, we use a negative sign, right? So why are we using a negative sign? You imagine your Cartesian plane. You know that your Cartesian plane, you have your 0 there in the origin, and then from 0 going up, it's your positives. From 0 going to that side, it's your positives. From 0 going that side, it's your negatives. And from 0 going that side, it's your negatives. So that is why something that is going downward to the left, we use it as negative, right? So we say, when you calculate, you just say -3 newtons, right? But in your final answer, you must not write, you must always write your answers in a positive form. And then if it's like this, you just write 3 newtons to the left. That will tell you, examiner, that you understand the direction, right? So we also have what we call the net or the resultant force. The net or the resultant force simply means that you have, it's the single effect, right? It's the single vector. Let me say it's the single vector that is the same effect as 2 or more vectors together. So by a net or resultant force, we simply mean that you must add those two. So when they say give us the resultant force here, or the F net, right? So the F net here will be what? Will be, let's say this is F1 and this is F2. That will be F1 plus F2. What is the magnitude of F1? It is 5. What is the magnitude of F2? We have to subtract 3 because it is going in the opposite direction, as I just explained. So it will be minus 3. So your answer will be 2 newtons going where? To the right. Why is it going to the right? Because it means that the remaining is here. The remaining is here, right? I hope to cover the same distance. This 5 started here and it ended here. This 3 started where 5 ended and then it is going back. So it left 2 newtons to the right because it is positive. We can't say up because we had nothing that had to do with vertical motion. I hope that really makes sense, right? So that is and another one is that this one was the one example of when they have opposite directions. When they have the same direction, it will be the same thing, but now the only difference will be that you'll be adding them, right? So let's say maybe they tell you that it is going there and the force is 5 newtons. And then when it ends there, there's another one that goes like, let's say 4 newtons, right? So when they say give us the F net, again, it will be F1 plus F2. What is F1? It is 5 newtons. What is F2? It is 4. Because they are going in the same direction, so there's no need for us to subtract them. So it will be 9 newtons going where? To the right. And they can do the same way as they are going in the opposite direction. That one ends there, and then that one ends there. Let's say that one will be 5 newtons, and that one will be 4 newtons. In this case, it will be still 9 newtons, but here when we put it in calculations, since they are both going to the left, it will be -5 minus 4. Why minus? Because it's -5 minus this one, because they are both going to, remember that this negative is telling us that they are both going to the left. So -5 minus 4, that is -9. So remember that in your final answer, you must always write it in positive. So it will be 9 newtons to the left, right? So I hope that makes sense. I really, really hope that makes sense. So there are 3 methods to describe the direction of a vector, right? We can describe it in this way with left and right, but they make it more complicated than this because this is very simple when they put angles, right? So we can, let me just simply do this, right? There are 3 methods. It can be represented on a graph, right? And it can be represented on a bearing, and it can also be represented on a compass, right? Or what we call the cardinal points, right? So it can be represented on a compass as well. So it can be represented on a graph bearing and the compass, right? So let's say on a graph, obviously they will give you a Cartesian plane like that, and then they give you maybe the force. They tell you that force is 10 newtons or something like that, and then they tell you that from here to there it's 30 degrees, right? So obviously, when you find your answer and you want to represent this, or when you're writing it down, you simply say it's 10 newtons at 30 degrees above the positive axis, right? So here on the graph, we simply say 30 degrees above positive axis or 30 degrees below positive axis, right? That's all you say, right? That's all you simply say. Or let's assume that they gave you something that was here and it was something like 12 degrees, right? So how would you represent that one? You simply say that, let's say the force was 5 newtons, right? You'll simply say 5 newtons at 5 newtons at 12 degrees to the left of the negative axis. So these are the negative axis, but you won't use all these ones. You just simply use what they make life easier for you guys, because when you write degrees, there's no need for you to write whether to the positive axis or negative axis, right? They just know. But I'm just giving you the simple the methods that they use. Another one is that you use your pairing. But in your pairing, what you should know is that it is the opposite of this one, because on your graph, your 0 degrees is always here. But in your pairing, your 0 degrees is always in your north, right? So in your pairing, it's like you are starting from there going that way. Whereas in your graph, you are going anti-clockwise. Whereas in your pairing, you're going clockwise, but your 0 is there. So your 90 degrees would be here, your 180, your 270, your 360 would be there. So using the same force, let's take that F being 10 newtons And obviously it means now this can no longer be 30 when you're representing it in the bearing. So from here to here, if from here to here is 30, it means from here to here is what? Is 60 degrees. So we won't use this 30 degrees, we will instead use that 60 degrees. Do you understand? So when you write this one down, you'll say 10 newtons on a bearing of 60 degrees. So when you mention the word bearing, we know exactly that now the 0 degrees is in the north. I hope that makes sense and I'm not confusing. And then when we go to the compass is easy. You just simply write north of east. Let's say the same example. We have got 10 newtons. So you'll simply say that you have 10 newtons. This one, it uses the same method as this one, 0 degrees goes that way. The only difference is the bearing one, right? So you'll simply say 30 degrees north of east, because you remember that your compass is, you have your north, you have your south, you have your west, and you have your east, right? So you say 30 degrees north of east, not northeast. The moment you say northeast, northwest, southwest, you only use those terms when your angle is at 45 degrees. But if your angle is not at 45 degrees, you say north of east, not northeast, right? Northeast and north of east is not the same thing. When you want to say northeast, northwest, southwest, southeast, you only use those terms if it's 45 degrees. But if it's not 45 degrees, you say 30 degrees north of east, maybe let's say maybe 100 degrees north of west. You understand? So those are the things that you should make sure that you understand and you don't mix them up, right? So with all that being said, all those vectors and everything, they were just an introduction to help you to do what? To understand the motion in one dimension, right? When we say motion in one dimension, we mean that we are only focused we are not focused on the object going up, down, and to the left and right. No. When we are saying that you are focused on one dimension, you are either focused on the vertical or the horizontal, right? So there are certain things that you have to understand, right? There are certain words that you have to understand. Words like your position, right? So for your position, we use or we depict it as X, right? That's your position. Your position simply means that the place where an object is relative to a reference point, right? The point that it will be in relation to a certain point. You can't say a position if you don't have a reference point. Always when you're talking about a position, you should have a reference point, right? So let's say that I have something like that, and this is my reference point, and this is, let's say, position 1, and that is position 2. I will say at position 1, it is 5 meters away from this. So I'm using A as my reference point. I'll say 1 is closer to A than 2. How did I know? Because I'm using that one as a reference point. I hope you understand what I mean by reference point, right? So a reference point is simply a point from which the position of the object is measured. It is the 0 point, actually, the reference point, right? I hope that makes sense. And then another thing that you have to know is your, what you call, it's your speed, right? So another thing is your speed. So I introduce formulas as well, right? Another thing is your speed. So for your speed, remember we said that your speed is your scalar quantity. So for your scalar, remember that it only has magnitude. So for your speed, we use V, right? So your speed is measured in unit and okay, let me do this. In position, when we don't want to say position, also but we don't depict it as this. Okay, let me leave it there because I'm confused. This is the displacement, right? We have a distance. Displacement, let me explain the difference between displacement. If you start from point A and then you travel and you walk until you reach, let's say, point B. All this traveling and whatever, we call that the distance. But what is the displacement? The displacement is simply cutting the distance short. When you move here in a straight line today, that is the displacement. All this, whatever you did, walking, going that way, left, to the right, left, whatever, that is the distance. But when we calculate from A straight to B, that one, we call it the displacement. So the displacement, you calculate it using meters. Those are the units, right? Meters. But you depict it as just m. Your speed is using your meters per second, right? Your speed is using meters per second, and your speed is a scalar quantity, right? So when you're talking about speed, there are certain things that I want you to remember. There's what we call constant speed. There's what we call average speed, right? We have constant speed, we have average speed, right? So with constant speed, we mean that you cover the equal distance in equal time intervals, right? So if it took you an hour at the speed of 50 meters per second, for the next hour, if you travel 50 meters per second also, we call that constant speed. Nothing changes. Both the distance and the time you cover are the same, right? Whereas with your average speed is the total, right? Is the total distance that is covered in a total given time. That is average. The total distance you cover in a certain total amount of time. And then the formula we use for speed is given by what? By distance over change in time, right? Speed is given by what? By distance over change in time. And then we also have another term we use, which we, before I forget, we call the instantaneous speed, right? Instantaneous. Instantaneous simply means that is the speed that is of the object at a specific moment in time, right? At a specific moment in time. Remember, constant, we said after a certain amount of time. Average, we said the total time, right? And then with your instantaneous, we mean when we say the speed at 3 seconds, right? We are being specific. That is the instantaneous speed. Now, since we spoke about speed, it's only fair to go and discuss the velocity, right? Because they are the opposite of, not really the opposite. But remember that your speed is a scalar quantity, whereas your velocity is a vector quantity. So your velocity is measured in, it also, let me erase it so that I don't confuse. This one is also depicted as V, but we like to put this arrow on top to show that it is a scalar quantity. Now we are being specific, we're talking about velocity because they both have V, right? So you know that your speed won't have direction, you just simply write meters per second, right? Also, your velocity, the units are meters per second. So that is why you have to be specific and put this arrow to show that it is a vector quantity, right? So the same thing, we have the constant velocity, we have the average velocity, and we also have the instantaneous velocity. So if you understood those terms in the speed, it's the same thing. You simply apply the same things in your velocity, right? So, but your velocity, remember that the formula for speed was distance over time. The formula for velocity is displacement. Remember I said for displacement, we use x, right? So it is the changing displacement over change in time, right? That is your velocity, right? Don't confuse it with your speed. I hope that makes sense. And then the last variable I want us to talk about is your acceleration, right? The last variable that I want us to talk about is your acceleration. So for your acceleration, we denote it with A, right? We use small letter A. So your velocity is simply what? Your velocity is the rate of change of velocity. Rate of change of velocity. What is your velocity? Your velocity is the rate of change of position. Change of position. Acceleration is the rate. When we say rate, it means that time is involved. Every time when we say rate, it means that time is the denominator. When they say rate of change of velocity, they mean that the velocity will be the numerator, whereas your time will be the denominator. When they say rate of change of position, they mean that your position will be the numerator, your time will be the displacement. I hope you understand, right? So these things are self-explanatory. In other words, in acceleration, we measure how much the velocity changes every second, right? How much the velocity changes every second, right? So this acceleration is given by what? By the change in what? In velocity over the change in time. When we say change in velocity, we mean that the final velocity minus the initial velocity. Change in time, the final time minus the initial time, right? I hope that makes sense. And then for acceleration, we have constant acceleration. Constant acceleration is a constant increase or decrease in velocity, right? So we also have what we call positive acceleration and negative acceleration. When we say positive acceleration, is increasing the velocity plus the direction, right? Or decreasing both of them, right? So that is positive. When we say negative, it's decreasing the velocity in the negative direction. When the car moves from rest to, let's say, 50 meters per second, that is positive acceleration, right? That is positive acceleration. But when it reverses, we remember that when it reverses, it's going to the opposite side. So we use the negative sign. So that we will call that one negative acceleration, right? I hope that makes sense. And we also use the term deceleration. In deceleration, that is the non-specific term that means an object is slowing down, right? When we say the object is slowing down, we say it is decelerating, right? I really hope that makes sense. Now, with all those things being said, we use what we call the equations of motion, right? We use all these formulas, but we apply what we call the equations of motion. The equations of motion they are simple, good people. You don't have to crank them because I think they will give you in the formula sheet, right? So what you have to understand is when to apply which one, and it all goes back to understanding the statement and being able to substitute. That's all that you have to do, right? So there are four of them. The first one says that for you to calculate the final velocity is given by what? By the initial velocity plus the acceleration multiplied by changing time, right? That is the first one. The second one says that if you want to calculate the final velocity again, that will be given by the final velocity squared and your initial velocity squared plus you 2 times your acceleration and changing displacement. And your third equation says that if you want to calculate the displacement, your displacement is given by half of your final velocity plus your initial velocity, and then all of that multiplied by changing time, right? I hope that makes sense. And then your another one says that if you want changing or if you want your displacement is given by what? By half times your acceleration change multiplied by change in time squared. This squared is only for change in time, right? So those are the formulas that you have to know, right? So what you will simply do from there is simply substitute and plug in all those formulas, right? So I'll give you scenarios where you simply plug in this formula. So when, let's say, for example, they tell you that you have a racing car that is moving from rest. Always when they say something is moving from rest, it means the initial velocity is 0. Always when they tell you something is moving from rest, it means that the initial velocity is going to be 0 meters per second, right? Rest means it was at rest, it was standing still, so there was no velocity, right? I hope that makes sense. When they mention constant velocity or constant speed or constant whatever, if they say constant acceleration and they didn't give you acceleration, it means that you will use 0 for acceleration. But if they say constant acceleration, but they give you, that is the amount, that is the constant amount, right? I hope that makes sense, and I really hope you understand, right? So I don't want to take too much of your time, but it is something also when you are using these formulas, you will use you will have to draw graphs as well, right? Or they will give you graphs to interpret. So when you're given graphs to interpret, you can interpret 3 types of graphs, right? They can give you a graph whereby you are checking the displacement versus time, or you're checking the velocity versus time, or you're checking the acceleration versus time. Those are the 3 graphs that you have to do. But the easiest way I want you to know in all those 3 graphs, either you draw them. If you're drawing them, it's easier because the values will be given, but most of the time they will give you the graph and ask you to interpret. So this is what I want you to know, right? You have to know the gradient and know the area of the graph. Now, this is what I want you to know. The gradient, obviously, you know it from maths that it is the change in y axis over the change in x axis. So it's simple that way. So if you're given a graph like this, right, and the graph was going up like that, you simply choose 2 points, any 2 points. You can choose that point and that point, right? And then you simply connect those 2 points, and then you take your obviously these are your y axis, these are your x axis. So remember that your gradient is y2 minus y1 over x2 minus x1. But really, you'll be focusing on which one you're dealing with right here. Let's assume that this one was representing you changing x and displacement, and this one was representing your time. Your time will always be in the x-axis. So you'll simply say here, it won't be your y2 will be the displacement there, and then your y1 will be the displacement here. And then you remember that you must choose this one is 0.1, that one is 0.2. So it's y2 minus y1, x2 minus x1, right? The time there minus the time there, right? So that will be your gradient. Your area is simply meaning that what do we have under the graph? That is your area. The whole portion we have under this graph, that one is your area. Now your area, I want you to know the area of two things. The area of your triangle, which is given by what? By half base multiplied by height. And your area of a rectangle, which is given by length multiplied by breadth. Now, I'm going to explain why I'm giving you these things. Now, you must listen carefully. Now, this is what you have to do. They can either ask you in terms of changing displacement, they can ask you in terms of velocity, they can ask you in terms of acceleration, because those are the things you are seeing: changing x, velocity, and acceleration. Now, you must listen to me carefully. When you are changing from, when you want the gradient of the changing x over t, that will give you the velocity. I repeat, the graph of changing x over t will, when you calculate the gradient of any 2 points, that gradient represents your velocity. The graph of velocity divided by time, when you want the gradient of that, that represents the acceleration. So this side is your gradient. That's the easiest way to remember it, right? I hope that makes sense. And then when you are given the graph of acceleration versus time, when you calculate the area of that one, that will give you the velocity. When you calculate the area of velocity versus time, that will give you what? The acceleration. So this side represents the area. That's the easiest way I remember it. I hope that makes sense. Good people, I'm a bit scared that time will be against us, but that's all that you have to understand. That's all that you have to understand from grade 10, except the ticker timers. The ticker timers, that is where they put the tape, the practical that you do, and they put a tape. But that one is not really a problem if you understand these things, right? So I think that will be it from me on grade 10 mechanics, because I've really literally given you everything. If you understand, especially this part, right, and then you shall be sorted. So I think that will be it for this video. If you have any questions, you let me know. Thank you.